ammonia is reacted with the hydrochloric acid, it forms a white fumes of ammonium chloride. Hydrogen oxygen with the chlorine, one more oxygen atom which has been increased, hence it is chloric acids. Suppose if I take the equimolar mixture of iodine with the chlorine, we got a chloroiodine interhalogen compound. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called the P block elements. Under this unit, we have discussed about the general properties of group 17 elements, and we have discussed that what are the elements which are belonging to the group 17 and their electronic configuration, preparation, chemical property and their uses of chlorine we have discussed. In addition to this, we also discussed about the electronic configurations of entire group 17 elements. Today, we will step up and we will understand the remaining topics of this unit by understanding the topic of hydrochloric acids, which are the compounds of chlorine. Okay. Next, the chemical properties of hydrochloric acid, the uses of hydrochloric acid. Then, we are going to understand what are interhalogen compounds. Okay. And preparations of interhalogen compounds, physical and chemical properties of interhalogen compounds we are going to understand by this session. Okay. So, firstly, we will see what are hydrochloric acids. Okay. We all know that hydrochloric acid we generally used as one of the laboratory chemicals in our chemistry laboratory, right? Their preparations we will understand first. Okay. This is an acid and it was first prepared by Glauber in the year 1648 by heating the common salts of sodium chloride with concentrated H2SO4. Okay, and later the Davy in the year 1810 they proved that the compounds of it is a compound of chlorine. Okay, so who discovers for the first time in the year 1648? Okay. The Glauber was the first person, he prepared this hydrochloric acid by taking the salts of sodium chloride which has been treated with concentrated H2SO4. Later he come to know that it is a HCl and it is an acid. Later the elementary nature and its property and its related to the compounds of chlorine was proved by Davy. Okay, we'll see how to prepare this hydrochloric acid in the laboratory. Okay, in laboratory, it has been prepared by heating the sodium chloride with concentrated H2SO4. So, how we can prepare? First, we have to take the salts of sodium, that is sodium chloride. We have to heat it with the concentrated H2SO4 at a temperature around 420. What does it forms? Sodium combines with SO4 with one hydrogen and forms a sodium bisulfate with the formation of HCl. Okay, this is the first method. Similarly, if you take that sodium bisulfate, again allow to react with the sodium chloride at 823 Kelvin. Again, the sodium bisulfate will be converted into sodium sulfate and HCl will be formed. Okay, this is one of the important method of preparations of hydrochloric acid in the laboratory by using sodium salts, that is by using sodium chloride and by using concentrated H2SO4 we can prepare what? Hydrochloric acids. Okay. Next, we will understand the chemical properties of this hydrochloric acids. First, we will understand their acidic characters. In a gaseous states, it is a covalent in nature, but it ionizes and in water to give a large extent and behave like a strong acids. So, when it is in the gaseous state, it shows its covalent nature. When it is dissolved in water, it gives rise to what? H plus ion. Thereby, it indicates that it is acting like a strong acids. You can see that hydrochloric acid, if you dissolve in water, remember it is in gas. When it is dissolved in liquid, it gives rise to the H plus ions to the water. Thereby, it forms a hydronium ion and chloride ions will be released out. This reactions are indicates that usually this hydrochloric acid, when it is react with the water, it can absorb one of the hydrogen ion. Thereby, it indicates that it undergo ionization process. Thereby, it produces one more H plus ions to the water molecule. Thereby, it forms a hydronium ion. By this reaction, we can clearly understand that hydrochloric acid will be acting like a very strong acids. Coming with the reactions with ammonia. So when ammonia is reacted with the hydrochloric acid, it forms a white fumes of ammonium chloride. So hope you know that while doing the salt analysis with the inorganic salts in your laboratory, suppose if the salts which is consists of ammonia, if you add the concentrated HCl, it forms a dense white fumes. That is mainly because of formation of what? Ammonium chloride. Okay, and next is aqua regia. So for the 1 mark or for the 2 mark, they definitely going to ask what is aqua regia and where exactly this aqua regia will be used. Okay, aqua regia, it is a mixture of concentrated HCl with concentrated HNO3 in 3:1 ratio. What is that? It is a mixture of concentrated HCl with concentrated HNO3 in a 3:1 ratio. Okay, this is known as what? Royal water or aqua regia. Okay, and it dissolves many noble metals. I'll explain with the reactions. Okay, here I have a gold, which is a noble metal, which is allowed to react with the H and Cl from the HCl, and you can see that this is a nitrate ion which has been formed from the HNO3, that is in the mixture of aqua regia. Okay. Okay. So what does it forms? The gold combines with a chloride and forms a complex compound, and also with the release of nitric oxide, and you can see that water molecules which is also get released out. Similarly, you can see that the reactions of platinum with the nitrate and H plus and Cl minus ion, it forms a hexachloride of platinum. Again, this is a complex compound with the release of nitric acid as well as with the nitric oxide with the release of water molecule. This indicates that this aqua regia will be mainly used to dissolve most of the noble metals such as gold, platinum, etc. Okay, to form a complex compound. Next is the hydrochloric acid decomposes the salts of weaker acids. We'll see how does it also decomposes the weaker acids. Okay. So first I'll go with the sodium carbonate, sodium bicarbonate and sodium sulfite. Okay. So when a HCl which is reacted with the sodium carbonate, it forms a sodium chloride with the release of carbon dioxide. This reaction which is indicates that the carbonate salts, which are the weaker acids, which is undergo decomposition by the action of HCl gas. Okay. Similarly, sodium bicarbonate, if it is react with the HCl gas, again it forms a NaCl with the release of carbon dioxide. Again, this reaction which is indicates that the bicarbonate salts which is also get undergo decomposition by the action of HCl gas. Similarly, the sodium sulfide which is undergo reaction with the HCl to form a NaCl with the release of sulfur dioxide. So, by that at the end of the reaction you can see that there is a release of carbon dioxide gas and sulfur dioxide gas. This reactions which is indicates that even though that the acids are weaker in their nature, it can be easily react with the acid to form a decomposition reaction. Thereby it releases the carbon dioxide and sulfur dioxide gases. Next is uses of hydrochloric acid. Already I have explained that hydrochloric acid is one of the important laboratory reagent, and one of the main applications of this hydrochloric acid is aqua regia, which is also known as what? Royal water. It is mainly used to dissolve the noble metals. Okay. In the preparations of chlorine and chlorides and in aqua regia, we use what? HCl. That is an important reagent. As a laboratory, it is used as an important laboratory reagent, as well as in the medicinal field also. This HCl, that is hydrochloric acid, which play a very important role in the extraction of the glue from the animal tissues as well as from the bone. We use a hydrochloric acid for cleaning of iron sheets during the tin plating, as well as in the galvanization process. We use this hydrochloric acids. So, hope you have understood with the hydrochloric acid and its uses and their chemical property. Okay. From the examination point of view, remember they can ask you what is aqua regia or royal water. So, you have to remember that it is a mixture of concentrated HCl with HNO3 in 3:1 ratio, and it is mainly used to dissolve the noble metals. Okay. Next is oxoacids of halogen. After understanding the halogen, that is a group 17 elements in the periodic table, we must understand the oxoacids which has been formed in the halogen. A halogen oxoacid is an acid which has hydrogen, oxygen along with a halogen atom, but we know that the halogen in that group, the fluorine is one of the exceptional element from the rest of the halogen elements, right? Because it exhibits only the -1 as their oxidation state, and we will understand whether that fluorine will also give the oxoacids or not. We will understand now. Okay, the fluorine will yield only one oxoacid, that is known as hypofluorous acid. Okay, because of its high electronegativity and its smaller size. Okay, so if you consider the fluorine, chlorine, bromine, iodine and astatine, we know that fluorine is only the element which is exceptional in the cases, and it shows different behavior from the rest of the element. Even though it looks different, it forms only one oxoacids, okay, and that is known as what? Hexafluorous acids. Okay, and remember why it forms only one oxoacid? Because it is having the high electronegativity and it is having very small size, and it exhibits in a -1 oxidation state. That is why you know it having only one oxoacids. Whereas the rest of other elements, you know, it forms a number of oxoacids. We will understand one by one. Okay, the chlorine, bromine and iodine mainly forms a 4 series of oxoacids. They are namely hypohalous acids, halous acids, halic acids and perhalic acids. So, the chlorine, bromine and iodine, okay, because this is a radioactive astatine as we know. The chlorine, bromine and iodine, they forms a 4 different types of haloacids or oxoacids, you can say, okay. 4 types of oxoacids, which are those hypohalous acids, halous acids, halic acids and perhalic acids. We will understand what are those and how it will be looks. And remember, although these are also known only for the solution or salts. Usually, when we look into the oxoacids of this halogens, they are not stable up to some extent. They are available only in their salt formation. Okay, that is in the aqueous solution we can see their stability. Next is oxoacids of halogen. Here you can see that the names of the oxoacids I have represented here, that is hypohalous acids, halous acids or halides, halic acids and perhalic acids. So you can see that the oxidation states of this halogen in each oxoacids will be different. So first we will see with the chlorine, bromine and iodine. Already we have understood that both the chlorine, bromine and iodine, they forms a 4 different types of oxo acids and their name, what is their oxidation state, we will understand one by one. First I'll go with the chlorine, and the oxo acid, the first formation of oxo acid with a +1 oxidation state is hypochlorous acid. Why it is known as hypochlorous acid? Because it is a chlorine. In general, we say it is hypohalous acid. Since it is a chlorine, we say it is hypochlorous acid and it is written as HOCl. Okay. Coming into the second one, that is halous acid, which is known as what? Chlorous acid, and their oxidation state will be +3, where you can see that it is having HCl with O2. From hypochlorous acid to the chlorous acid, you can see that one oxygen which has been increased. The third, the oxo acids of chlorine is chloric acid, and it has the oxidation state of +5, and also you can see that it has the representation of HCl with O3. You can see that again one of the oxygen which has been increased. The fourth oxo acids of chlorine is perchloric acid and it is represented as HClO4. Again you can see that it is having one more oxygen atom which is increased as compared with the chloric acid, and it is exhibiting a +7 oxidation state. Similarly, the bromine, which also exhibits 4 different types of oxo acids. They are hypobromous acid, they are written as HOBr, and bromous acid, that is HOBrO, and bromic acid, you can see that HOBrO2, perbromic acid, that is HOBrO3. From hypobromous acid to the perbromic acid, you can see that number of oxygen atom is again increased. Coming into the iodine, iodine will form only 3 types of the oxo acids. They are hypoiodous acid, iodic acid and periodic acid. There is no formation of the halous acids in case of iodine. Okay, and you can see that HOI, HOiO2, HOiO3. Again you can see that number of oxygen atom which is also increased as we move down. And you can see that this is the general representations of oxo acids of the halogen. So first we will see only the oxo acids of chlorine now. So these are the oxo acids of chlorine. Already we have understood that chlorine will shows 4 different types of oxo acid. Similarly with the bromine, whereas iodine will shows only 3 types of the oxo acids. Whereas our fluorine, remember it shows only 1 types of oxo acid, that too hypofluorous acid. Okay, so first one is hypochloric acids or hypochlorous acid, you can say. You can see that the general formula is HOCl, and you can see that there is a 1 chlorine atom, 1 oxygen with 1 hydrogen. So what are the oxo acids here? The oxo acids are the acid where it consists of oxygen, hydrogen with 1 halogen atom. Right? Then only we can say it is oxo acids. So it is hypochlorous acid, and again all the structures are very important for the examination point of view, either for the 2 marks, either for the 1 mark. They can ask you to write any one of the oxo acids of the chlorine. Chlorous acid, again you can see that the basic chain is HOCl, but in addition to the O, we have 1 more oxygen, hence it is written as HOClO. Okay, and you can write this is also as HClO2. That is chlorous acids. And from all the structure, we have hydrogen, oxygen with 1 halogen, but number of oxygen atom will be going to be increased. Coming into the chloric acid, again you can see that hydrogen, oxygen with the chlorine, 1 more oxygen atom which has been increased, hence it is chloric acids. Remember it has +1 oxidation state, +3, and this is +5, and the last one is +7. That is perchloric acid. You can see that we have hydrogen, oxygen and Cl, and again one of the oxygen which has been increased, hence it is perchloric acid, and general representation is HClO3. And for this is HCl O3 and this is it is O4. Okay, this is how the oxo acids of the chlorine will be written, and in the examination any one of the structure will be given to you and you need to write the structure of that given compound. Okay, and it is very easy to write that compound. Next is interhalogen compounds. Already we have discussed that what are interhalogen compounds, right? So what are interhalogen compounds? These are the compounds which are formed by the reactions between two different halogen atoms. Then it is said to be interhalogen compounds. Okay, the interhalogen compounds are formed when two different halogens are react with each other and they can be assigned with the general representation of XX dash, X dash, XX dash thrice, XX dash 5, XX dash 7, where X stands for halogen and X dash is also another halogen atom, and X is a halogen of larger in size, whereas another X dash is smaller in size of the halogen atom. Okay, so what is the X here? X is a halogen with a larger size. Okay, larger in the size, and X dash is a smaller in size, smaller size of the or smaller size halogen atom you can say, and X is more electropositive than X dash, so the X should be more electropositive in their nature than that of the X dash, then only the interhalogen compounds will be formed. Okay, the ratio between the radii of X and X dash will be increases and the number of atom per molecules which is also get increased. We have types of interhalogen compounds. The first type is AB, AB3, AB5 and AB7, and it is also written as XX dash, XX dash thrice, XX dash 5 times, XX dash 7 times. And the examples will be goes like this, that is chlorine with the fluorine, bromine with the fluorine, bromine with the chlorine, iodine with the chlorine, iodine with the bromine. You can see that the first element which is more electropositive than that of the second element, okay, and the first element size is bigger than that of the first element. Okay, this is how the interhalogens will be formed. Okay, then AB3 type will be, examples will be goes like this: ClF3, BrF3, ICl3 and IF3. Similarly, for AB5 we have Cl5, Br5 and I5. For the AB7 we have only one type, that is IF7. Okay, remember always the first halogen atom should be in the larger in size, second halogen atom should be, or a halogen element should be smaller in size, and first halogen atom should be more electropositive than that of the second halogen atom. Then only the interhalogen compounds will be formed. Next is preparations of this interhalogen compounds. Okay, by the direct combinations of two different halogens, the product will be formed depending upon the specific conditions which has been employed. So already we have understood that interhalogen compounds are the compounds it is formed by just by reacting with the two different halogen atoms. If the reactions conditions are different, the product formations which is also get differs. We'll see if we change the reaction condition, how does the different product will be formed. Okay, the first reactions will be goes like this. Here I have a chlorine reacting with the fluorine at 473 Kelvin. By taking its equal volume, we get a interhalogen of chlorine with the fluorine. Similarly, if I take the chlorine in excess than the fluorine at 573 Kelvin, it forms what? Tetrafluorochlorine will be formed. Okay. Suppose if I take the equimolar mixture of iodine with the chlorine, we got a chloroiodine interhalogen compound. Suppose if I take the iodine in excess quantity than that of the chlorine, we get a trichloroiodine interhalogen compound. Suppose if we take the bromine and fluorine which is diluted with the water, then the product will be trifluorobromine. Again it is an interhalogen compound. If we take the equimolar mixture of bromine with the fluorine, we get a pentafluoridobromine interhalogen compounds. This indicates that even though the halogens are different, if you change the reaction conditions, the product formations which is differs. Okay. Next is physical properties of this interhalogen compounds. They are all covalent molecules and they shows their diamagnetic nature. Their physical properties are intermediate between the constant halogen, but the melting point and boiling point are higher than what we are expected during the reactions. These are the physical properties of what? Interhalogen compounds. Coming into their chemical reactivity, we will see how does this interhalogen compounds will also shows a different chemical property. The interhalogen compounds are more reactive than the halogen except fluorine. Okay, except fluorine, most of these interhalogen compounds have become very reactive. That is mainly because, suppose if I take iodine with the bromine, or else you can take iodine with the fluorine. Okay, so or else you can take chlorine with the fluorine, like this, any one of the interhalogen compounds if you take. Okay, we know that the bond between iodine with the bromine is usually weaker. Okay, as compared with that of the I and Br and with the Br. That is what the sentence state is. This is because the AB bond in the interhalogens is weaker than that of the AA and BB bonds in the halogens. So if you see that interhalogen compounds, the bond between the two halogen atoms is always weaker as compared with the bond between the two halogen compounds. This is only the case which indicates that interhalogens are more reactive than the halogens. Okay. Then coming into their hydrolysis, the interhalogen upon treatment with the water undergo hydrolysis to give a halogen acids of small halogen and oxohalogen acids of larger halogen atom. The halogen of the type AB which gives the hypohalogen acids, whereas AB3 which gives a halous acids, whereas AB5 which gives a halic acid, whereas AB7 which gives a perchloric acids. So if you take any one of the halogens, suppose if I take the AB3, AB5 and AB5, upon hydrolysis, the product what we are expecting, that is nothing but a halogen acids what we are expecting. It will be differ with the AB, AB3, AB5 as well as with the AB7. So as it varies with the interhalogen compounds. Next is, it is just a recap of types of interhalogen compounds and their physical state along with the formula. So it is not necessary to read this for your board exam, but again it is very important for your competitive exams. Have a look on it for especially with your CET as well as for your NEET. From this part they can ask any questions. Okay. So first type is XS-1. So we have only 4 types, that is CLF, BRF, IF and ICL. Usually the CLF will be colorless gas, BRF is a pale brown gas, whereas IF is an interhalogen which has been detected spectroscopically with the gas, and ICL is a ruby red solid which is in the alpha form, whereas it also exhibits in a brown red solid that is in a beta form, and you can see that there is no structure which has been exist. Okay, coming into the AB3 type, that is we have 5 types, that is I, Br, Cl, F3, BrF3, IF3 and ICl3, that is trichloroiodo. Okay. So the first one, that is bromo-iodo compounds, will be a black solid. The ClF3 is a colorless gas. BrF3 is a yellow-green liquid. IF3 is a yellow powder and ICl3 is a orange solid. All of this, will exhibit the bent T-shaped structure. Coming into the AB5 types, we have only 3 forms, that is IF5, BRF5Cl5, and it shows colorless gas but solid below 77 Kelvin, and it is colorless, and ClF5, which is also colorless liquid, and all these three forms will exhibit in square pyramidal shape. Coming into the AB7 type, we have only one type of formula, that is IF7, which is a colorless gas. It shows pentagonal bipyramidal in the shape. Coming into the uses of this interhalogen compounds. So it is a non-aqueous solvent, and greatly it will be used as a fluorinating agents in many reactions, and ClF3 and BRF3 will be used in production of hexafluoridouranium in the enrichment of uranium-235. It is one of the important applications of this interhalogen compounds. So in the next session, we are going to discuss more about the group 18 elements. So by this, I conclude that my topic, so whatever the things which I have done, that is especially with the hydrochloric acid as well as with the interhalogen compounds, it is very, very important for the examination point of view. Have a look on it and try to work out. We'll meet you with the next session. Till that, take care, be safe. Thank you.